You are. Welcome to our Sembang AIoT channel. Again, me, myself, Cecily.
I'm 𝐃𝐘𝐘.
So we are still with you today. Every day, every week, I think we had this Sembang AIoT, the channel live for you in the afternoon of every weekend. Yeah. Today is a Friday. Same thing, very cloudy in Kuala Lumpur, in PJ, still very cloudy. So thank you for watching. So how often do you need to have some wireless device being connected remotely, or you want to implement certain IoT device, or you want to collect any IoT device, but you do not want to do any wiring? Yeah, if you have this issue, today will be a good time for you to watch. How you can realize the IoT wireless within your local network to collect data. Okay, so what about if, let's say, you want to, in the middle of planning how you want to use AI in some application, or you want to start up a journey of AI, So we are going to share something. Is going to share something with you on what are the methodology that you can use, or what are the standard, the AI development standard that you may tap onto. So that is another. I think we got 2 or 3 episodes to talk about that. Yeah. So I hope everybody is good, and I think it's quite a busy schedule. I think from the last past 1 week, it has been a very busy schedule for us. I don't know whether how about you, but most of our customers are quite busy, with their own thing. So I think in the past 1 week, I think we have been talking about the IoT sensors, from a temperature, from a pressure transmitter, and some of the sensors are being connected using a usual wired way, and then also we host the web API server, OPC UA server. And then also we are able to show you on the web, on the cloud as well. Now, these are the few things that we are doing. So next week, I'm going to share more other things in terms of PLC and so on. But today, I want to share something very light for you. It's actually one of the extensions from the past 1 week, session that we have done on the temperature monitoring. This part we are going to show you. Can we show my one of my slides? Yeah, that is on the IoT wireless sensing. How can you do, let's say you are having what they call the sensors maybe 1 kilometer away on another building, on another building, or on the big field. Some of the sensors, either temperature, humidity, or any other contact sensors that is remotely. Normally, how can you do? Yeah, so that is without, when you want to do this kind of data acquisition, you cannot be pulling the cable, crossing other people's properties. That will actually make you more troublesome, in terms of you want to get permission from authority, from people, in order to get some of the permission before you can do that. So today I'm going to show you how you can use a wireless array, one of the wireless. This, you can see in one of the setup here, we have this so-called a Lora transceiver, It is not a usual standard kind of Lora WAN gateway where you just listen to all the Lora sensors publishing data on the what they call a fixed interval. That kind of Lora WAN it is not. It's not. So this guy is having it has to be built in one pair. So you can see, in our this next page, this kind of topology, this is the topology that you can do. On the left-hand side, you can see also, we have this our usual IoT gateway, and then you can have a LoRa. You call it LoRa converter, or you call a LoRa host or LoRa transceiver. But it has to be done in a pair mode. So you may be talking to different LoRa so-called nodes. You can go up to 16 of them, and then every of them they can have a different ID. Then you can also group them. If let's say I have one LoRa transceiver host, I can be talking to 16 of them, but I can have another LoRa host that can be talking to another group of 16. But they can be configured in the different group. So you can see here, I don't know whether you can see from here, and this is one of the device that you can configure a device ID. They have a device ID. And when you connect to your computer or laptop or any of your system, you can also use a 232 to configure them in a different group. So you can have a multiple group and then multiple remote location that you can gather data from. That is a very unique way of, very flexible and a very unique way of gathering data over the IoT sensor. So today we also have a small setup, remotely. Our colleague, Amir, he's waiting at the other remote side. So this transmission actually goes up to the top floor. Not very far from here. But just for your information, this kind of a device usually, it works very well in the line of sight. Line of sight meaning you sit or you stand up there, you use the binocular, you can see no blocking. That is the line of sight that they're talking about. But in this LoRa, because LoRa, is running on how many megahertz? It's running on 800 to 900 plus megahertz. So in terms of penetration, I think I covered that before in a very early stage, but we didn't go until that detail. The penetration is better compared to 2.4G Wi-Fi. So when penetration is better, no matter how many obstacles that you are crossing, it won't be easily blocked. It can be reflected, and then it can somehow tunnel through, over the wave. So with that alone will resolve a lot of issue. For example, this guy, if let's say you are using that in the factory, you have a different machinery around. So since the penetration is better, so you can gather data through quite a large space. Even though it's a next door or even in the next building, this guy can do 1.5 kilometer away. So if you have some blockage, you can still within 1 kilometer away. It's still very practical. And then this guy can do multiple. You can talk to multiple remote location. In this case, at the same time also, can we share the last slide? That is how you can gather this data over a remote. That means in the local area network on the wireless, but on the other side, on the host side, you can still publish data to the cloud, for other people to visualize all the data. But with this kind of a topology or with this kind of a concept, you can expand, without even touching any of your surrounding. You don't need to dig a hole. You don't need to punch the thing to cross. You just set it up and then you can run. But there is one limitation here. What do you think? What kind of limitation you think that this guy has?
I think since it can transmit for a long range, I think maybe it requires a very high power.
Okay. LoRa, in the way that this part actually. High power, maybe it's not necessary. It's not necessary because LoRa, under LoRa or LoRaWAN is a kind of a low power kind of the device of low power. And then the frequency range, and it's fall under ISM band. ISM band actually you do not need to it's under one of the compliance. It's part of the ISM band, which is you do not need any licensing. You don't need to buy licensing. Some radio equipment or 400 megahertz on, some of them you need to pay for that kind of license, but this one you don't need. It's just like a Wi-Fi, but the penetration is better, and then the coverage is better. And one part, for example, we have this so-called, can you see this?
Very long route.
Just now I asked, what is that?
It's like a fishing rod.
It's a fishing rod. So this, let's say people like Joran, they want to fish. So this is actually an antenna, one of the antenna, because you see this part, you can have a very small antenna, and then also you can be extending to a 8 dB kind of antenna. So basically, if you see this kind of antenna, it's called omnidirectional. Omnidirectional meaning it go in the circular, covering the whole place. There's one type is a panel antenna, which is on the directional antenna. This is a quite powerful one. I think we have this one. Some customer used that before. Transmission and reception very well. That is one of them. So in most of the IoT applications, sometimes you do not know, some sensor is hiding somewhere. So you need that kind of tools, or you need that kind of gadget to get this one across. So without further ado, I think I will call, can Amil hear us on the remote side? Yes? No? Maybe you turn on. Yeah. Oh, hey, Amil. How far are we? I cannot hear you, Amil.
Hello?
Oh, okay.
Can you hear me?
Yes. We can hear you very well. Maybe Amil, you can explain to us. This is just like TV3 reporting. Just like TV3 reporting. Okay, Amil, can you explain to us what is the setup there?
So here I will show you. I will get a close look first. So you can see here this is one of our setup. So we have a Lora here. It's connected with our I/O module here, and then it connected into our temperature sensor road.
Yes.
You can see the road.
Yes. Okay, Amil, I have one setup here also.
Okay.
And one setup here also. So I believe we are actually connecting through a Lora network.
Yes,
that's how we connected together.
Actually,
Yeah.
you can see the light here. The yellow light, the blinking light.
Oh,
I
okay.
think.
Yeah, this is
So if it
some lights flashing here. Same thing also, I think Amil is having the light flashing. That is to indicate the transmit and receive of the data over the Lora network. So, Amil, are you still there? Okay, with that, I think the reception may not be so good at the remote side.
Yeah,
but
the
anyway,
Lora still very good.
the Lora is still working very well. So I just want to show you another part. Yeah. This is a place where we can measure the temperature. Okay, Amil, you're back. Are you back yet, Amil?
I don't think so.
Okay, doesn't matter. I think, Amir, if you can hear us, can you raise the temperature by burning something there to show whether this side is responding?
think the temperature now is around 31.4 degrees Celsius.
Yeah, this one is 7 divided by
100.
100 yeah, it's a 3000. It's actually 31.49, 31.5.
This morning when we do the setup, it's around 35.8. Oh, it's very hot. Now because it's going to raining soon, so the temperature drop.
Okay, this is outside. Yeah, this is outside. Okay, I think okay, Amir has connected using a phone. Oh, yes. Thank you. Amir, can you burn the... Oh, you are raising the temperature, huh? Okay, let me see. Let me see what we have here.
Amir said it to turn off the speaker that connect to the PC.
Okay. So what can we have? What do we have? So can we see the Okay, I think we have to go back here. Okay, Amil, I think it's enough. You have burned enough. I think the one it will be, you will burn some more. It will be
destroy the sensor.
Hangos already. Let me see. How can we get back? Yeah.
Turn on the screen then.
Okay, we turn on the screen.
Yes. Become 44.
So it's a 45. It's not so high, huh?
Oh, but the other one.
Oh, okay. It's not 44. You are burning the one. It's becoming. It's already over. Become 32,000 something. That is already hit because I think we didn't set the thing properly lah. That one is, I think, it's over 100 over degrees Celsius.
Yes.
Okay, Amil, thank you very much. So that is the actually I thought maybe that would be interesting to just show to some of our audience. These are the things that we can have. Okay, thank you very much, Amil. So we will.
Yeah, I think the temperature dropped already.
The temperature dropped already.
Already. It's dropping now.
So let me show them again. I think that one is over temperature. This one is about 80 over. Oh, just now you overburn, Amil. You overburn the sensor just now.
I think the sensor still survive.
Okay. Yeah. That is I hope that is a very interesting thing that we can show you, over the radio, and then over the radio LoRa network. On the remote side, we are collecting some temperature data. That is the wireless side. Of course, after getting all this data, is feeding to the gateway. Gateway is sitting here. So then that data can be published to the cloud, and you want to host the OPC UA, for other SCADA system or other client, OPC UA client to connect to it. That is possible. And then some of them asking about, what about, can I log the data? Can I log the data? So that can be also done, by just configuring using some of our IoT tools that you can, what they call, do some data logging locally. Yeah, that is beautiful thing about what they call the consumable, consumer kind of IoT gateway. Sometimes the storage is limited, but in this kind of Intel-based or PC-based or industrial PC-based, that kind of a concept, you can expand whichever you want. You want to put 1 tera, 2 tera, or 4 tera, it's up to you. You want to keep how long of the data, it's up to you. Yeah. So that is a beautiful part of the Edge Gateway, our IoT Edge Gateway. I hope you enjoy this one. Thank you very much for watching again. I think our subscriber has increased, I think we have increased from weekly 5, sometimes 10. I don't know where are you coming from, but anyway, This is our 22nd session, Sembang AIoT. Every time we start Sembang AIoT, we start with this Sembang bukan sebarang Sembang. Kami Sembang teknologi, kita Sembang AIoT. Okay, I hope you enjoy. Thank you for watching. And I think I want to pass on to Ken Leong to talk about the AI part. You know, how when you come to do some development, or you want to start something on the development, or you want to apply certain thing, you know, but you want to know the back end concept of the whole AI. You know, Ken Leong is going to show you video. But before that, you know, I think for this session, I think we have created what they call the group, not group lah. I mean, we have created a workshop, particularly helping people who do not. You want to get some awareness how this IoT or AIoT. We have this half a day workshop, workshop, and then we are giving this free. You know, we are giving this free to those who have just graduated, but within the 3 months, you have to fulfill the criteria. Within the 3 months, you couldn't find the job. But during this time, you want to upkeep yourself, you want to upgrade yourself to learn more about AI or IoT in this area. Especially, we are more onto the industrial AIoT. Yeah? So you want to learn more, you can go into our website, you know, we have this QR code there, you can scan. Or some of you who see this one, if you find your friends need this, you know, please share with him or her. We don't need to, do we need to have a specific industry? Let's say he has to come from electronics, or she has to come from electronics background, or IT. Do we need? Actually, you don't need. Yeah, you can come from any discipline as long as you have a will to learn. We are able to open this one to you. It's a free half-a-day workshop, sharing with you and giving you some kind of awareness in terms of application of AI and IoT. So if you are interested, you can scan our QR code at the left-hand side or right-hand side. Right, yeah, on the right-hand side. Okay, on the right-hand side, you can see. So, yeah, so you can register. We will get back to you, you know, when is the time. We will host this for you. Okay, Ken Leong, maybe it's your turn.
Okay, so for today's topic, I will talk about, usually after you train your AI model, then it's the time for you to deploy your AI model into your real environment. So, but how are we going to do the deployment? Are you going to deploy your big desktop PC, put into the production line, or put into your, if you are from the agriculture, you want to put this big desktop into your farm? Or if you are doing this thing for the retail, you want to put this desktop into the shopping mall or your shop. So this is something you've occupied the space.
Yeah.
So I think you're also looking for some device that is smaller size that can run your AI model. But at the same time, you will think that a smaller PC, does it have enough power to run your AI model or not? Because previously you give a big desktop inside, maybe equipped with the GPU. Then how this big GPU put into the small PC to run your AI model? So today I will explain on how we're going to do this thing.
Yeah, I think that is very true, you know, because along the way that along the whole journey, when we see different people applying different AI model, you know, they bound to have some environmental or so-called space constraint, or whether it's applicable, practical or not to put such a big system inside. You know, that's why we are. If let's say you look at our this what you call our this non-intrusive analog meter reading, we are using just a small tiny board or tiny system only. So in order to make a AI or IoT application more applicable, more practical, things has to be smaller, easy to house, and then able to stand that kind of environment. Yeah. So for your information, for example, ExamTech do have some device that can sit under the rain, under the sun, that kind of thing that we also have. Yeah. So maybe you can continue. Yeah. Thank you.
Yeah, I think I need to share the slide. Yes.
Yes.
Okay, so what you see here is a desktop PC. So usually when you want to start train your AI model, you need a PC. And definitely you need a CPU. Usually we will use the Intel CPU, and most of the deep learning framework that support the Intel platform, the Intel CPU. For the other type, like the AMD, that one also got, but not so popular. So for the CPU, you have the range from the Intel Atom, the Intel Celeron, and i3, i5, i7, up to i9. So this one, it will affect your training process. If you use a more powerful CPU, it can complete your job faster. But for me, it's not very significant. i3 from i7 to i9, actually, the improvement just a little bit only. So after you have the CPU, of course, you also need the RAM, the hard disk. SSD, of course, is run faster than the normal hard disk. So usually we'll use the SSD, is better. RAM, any brand also can. It doesn't matter. But if you have a higher memory, higher RAM, of course, it will help you to accelerate the training process. But if you don't have enough RAM, then it will cause some problem, especially before you even can start the training, because you don't have enough RAM to load the entire data set. Okay, so these are the deep learning framework that is commonly used by all the community. So we have the TensorFlow, Keras, PyTorch, this kind of thing. So by default, all these deep learning framework that support use the CPU to do the training. But using CPU to do the training is very time consuming. So I have there's a case that happened, I think 4 or 5 years ago. One of my colleagues, he didn't aware that he can use GPU to run training. So he used CPU to do it. And after half year of training, the computer run for 24 hours non-stop. After half year, the entire training process haven't finished 50%.
It's talking about that also, we have the same experience about during the last year, this one of the AIS. That one is without GPU also. So it took us about 2 weeks time to, you see, when you run for 1 day, you tend not to shut it off, because you think, maybe it's going to finish. But the second day also like that, the third day, it increased so little. So of course, because it involves a lot of mathematical calculation, right?
Yes.
What kind of calculation is inside?
Most of that is the convolution. It's a sum of multiplication.
Sum of multiplication.
The metric multiplied with a metric. And then the metric is not 3 times 3. It's I don't know how many thousand by how many thousand one.
Wow.
So it's a very big array. Array multiplied by array.
Okay.
So to solve this problem, so all these deep learning framework, they also support the GPU. So the very common one is the NVIDIA graphic card. So as long as you put an NVIDIA graphic card, it can accelerate the training process by I don't know how many times, but definitely a lot. The thing that requires 1 week to finish, maybe within 1 hour can finish already. So your desktop consists of a CPU and also a GPU. Usually it's like this for you to train an AI model. So, okay, now I will focus on the TensorFlow, because different deep learning framework will produce different things. So during the training process, it will generate some checkpoint files. In TensorFlow case, we call it a checkpoint file. So the checkpoint file actually is your AI model. So every how many iterations, it will produce a file. So you have a lot of this checkpoint file. Then at the end of the training, you will choose the best checkpoint file that gives you the best accuracy, and then you convert it become a protobuf file. So the difference between checkpoint file and the protobuf file is checkpoint file, it will contain all the parameter, even some parameter that never been used also inside. So the file size is quite big. And then when you convert into protobuf, you will remove those unused parameter, and your file size becomes smaller, and you can run faster. Okay. So actually, for the inference, you need the protobuf file to run it. So the TensorFlow, the deep learning framework, you can run the inference with the TensorFlow by using the protobuf file. Actually, the checkpoint file also can. Checkpoint file also can be used to run inference, but protobuf file is more better because the file size already been reduced and already removed some unused parameter. So training already finished. Now you go into the deployment. So usually people do is they copy the protobuf file into second machine, another PC. But this protobuf file, it requires if you train with the GPU, and then you run the inference, usually you will get the result that produced by the GPU. So everything run very fast because you got the GPU to accelerate your inference process. But imagine you need to calculate the cost of your desktop. If you're using an i7 CPU, and then you put in a graphic card some more, so the entire cost is very high already. And then you need to deploy to multiple production line or multiple sites. Then it's straight away multiplied by how many sites you have. Your cost is like that already. So if you can deploy into another device that doesn't require the GPU, also can run your AI model, then your cost will be reduced by a lot because the GPU is very expensive. Okay. So okay. So actually, usually your application might be at the agriculture or smart city, or at the factory shop floor. So all this kind of environment doesn't allow you to deploy such a big desktop PC. And what you need is something small. Like in this case, it's something as big as your hand only.
The palm size.
A palm size one. And you need to deploy into multiple. So if your AI model is not very heavy, actually it can straight away run in the CPU without the GPU. The GPU is, you just use it to accelerate the training process. The inference process doesn't require the GPU for certain model. For those lightweight model, we call it. So in order to achieve this, have the Intel OpenVINO, is an inference engine which accelerates the inference process. So it accelerates the inference process on it. It won't give any improvement in the accuracy. The accuracy depends on your training process. So how this OpenVINO do is from all the framework, you have on the top is all the deep learning framework. So it takes the input. So for example, just now the TensorFlow at the end generate a protobuf file. So the protobuf file will go into the OpenVINO. And then the OpenVINO will optimize it. It will convert into another format, and then which is suitable for the Intel CPU or the integrated GPU. For the Intel GPU, this is something recently released. They call it the Intel 𝐅𝐑𝐃𝐘. Intel also produced their own GPU. And then the VPU for the vision processing, and also the FPGA. So the OpenVINO can run on different Intel hardware. And then all this hardware can use on different OS, like Linux, Windows, Mac OS. Okay, so previously I mentioned the TensorFlow also can be used for inference. Then why we want to use the OpenVINO again? So from this chart, you can see, okay, for example, we take this YOLO V8 hex. So this one is the most heavy YOLO V8 version. So the yellow color is the inference time. The lower is better. So this one is produced by the OpenVINO. If you are using the PyTorch or other deep learning framework, the inference time is higher compared to the OpenVINO. So which means same AI model, but using different inference engine on the same hardware, you can generate different results.
Why is it so?
So this one is the secret behind the OpenVINO. OpenVINO, they did some optimization.
Okay.
So that you can fully utilize the power of the Intel hardware.
Okay, before you proceed, I think I just want to, some audience just came in, this is our Sembang AIoT channel. We have this one weekly on Friday, every 4 o'clock in the evening. Why we choose this session is because this kind of Sembang technology, I think it has to be more relaxed to hear or to watch, rather than during the beginning of the weekdays. So that's why we have this one at 4 o'clock in the afternoon. Please do SSL, subscribe, share, and like, if you enjoy this channel. And yeah, so that is a thing. But before you move forward, we want to introduce a king. Who is a king?
I don't know.
You don't know? Okay. Can you share our king, our friend Amil? Is he still there? Okay. Hey, Amil. So you're still there, huh? Yeah.
Yes.
So I just want to
Okay.
tell you, he is our YOLO king. Hey, YOLO king! Actually, me and Gelo, we want to make him a YOLO king, the one of AI model YOLO king, because he's helping us at the background to build all that kind of something related to YOLO.
Many type of application that use YOLO.
So you have a new name, Amil. You are a YOLO king. Yeah. Okay, thank you. Okay, Gelo, you can continue.
Okay. Okay, so from this chart, from the left-hand side, this one is the most top. We call it the smallest size of YOLO. YOLO V8, and I think maybe stand for nano, and then AS, and then the medium, and then the large, and then this one is extra large. So when the model size increase at the beginning, which means when the OpenVINO or other deep learning framework, when they handle the lightweight model, you cannot see too much improvement. But when the model getting heavy, the model size increase, you can see the OpenVINO start doing the job already. So it outperforms compared to other deep learning framework. Okay, so this is what happened in behind the OpenVINO. So after you train a model, you will generate a file. That one usually we call it as the weight file. It can come in protobuf or CKPT or any other format. So this thing, it will actually put into the model optimizer provided by the OpenVINO. So it's a software. So it will convert that file and then generate the IR. The IR means the intermediate representative. So it consists of 2 files, a bin file and an XML file. So these 2 files will be used by the inference engine. So because these 2 files will describe the structure of the neural network. And your user application, so you need to this one is your own application. So you will feed in your input image or your any other input into the inference engine, and then the inference engine will put the input, it will run the inference based on this XML file and the bin file, and then it will generate the output, maybe in a bounding box or some text or some sound, go back to your application. And from my experience, to write the inference code in your application using OpenVINO is much more simpler compared to using PyTorch or TensorFlow. That one, you need to write a lot of code. If you use OpenVINO, just fill out of code. It makes everything become more simple.
Yeah, looks like we are helping Intel to do some promotion here. So Intel have to give us some kind of sponsor.
Yeah, actually, OpenVINO is just one of the inference engine in the market. So besides OpenVINO, actually there's another. For example, from the NVIDIA, they also released their own inference engine. That one, they call it the Jetpack. The Jetpack is another library that runs in the NVIDIA product. So maybe next week I will talk about that one.
So generally, I think I'm seeing it as two branches. One of them more pro Intel, the other one will pro more NVIDIA, something like that, right? Is there a third one?
Yes.
Oh, what is the third one?
If I not remember correctly, that one is they call it Gradio.
Oh,
Gradio.
Another
library also doing the inference. And then they claim that some of the model that been optimized by them can run faster than OpenVINO. Certain model only.
So this guy actually chasing, they are competing each other, So right now, that kind of the competition actually is very healthy, very healthy. So that actually helped to promote a lot more in terms of application, in terms of usage, different area of application. I myself see that part as each of them has their own strength in a certain area, correct? Yeah. So that's why people when they're choosing. No, by the way, so in this let's say this coming workshop that we shared, we are hosting for free workshop for those fresh graduate. The criteria, the qualification eligibility is 3 months. You still haven't got any job. You want to do something on the AI or you want to do something on the IoT. Do join us. We will give you a free training for that part. That is also go in line with some of the government policy, trying to do more, give more, what we call talent, talent development. Maybe that is one part where you can start to get to know more about AI or IoT. Yeah. So some of the people they're asking about. Some of our audience they ask us actually, after our event, they watch the video and then he asks, what is this AIoT? Can this AIoT is this AIoT free? Or is this what we call AIoT software or hardware? That kind of question. Actually, you see, AIoT basically is a big term. Let's say I want to put a name to this AIoT in a more layman word, it will be because AI is talking about intelligence, simulated intelligence. So if IoT, we are talking about connectivity. To put it as simple as 2 words, would be connected intelligence. Yeah. So that connected intelligence is very powerful, right? Connected intelligence, so that is a thing that if you come to our this workshop, you will learn more. Yeah. So will you be covering some of these things in the workshop?
Yes.
Some concept.
Yeah, the OpenVINO is just a basic introduction.
You can learn. Now, if you have a friends or some of them they want to do, you want to learn, please let us know. That part we will have something something exciting for you, in your, let's say, in your future career, in terms of building your knowledge and so on. Yeah. So you cover that part. Okay, now sorry, you
I
finish.
think finished.
Oh, okay, now finish.
Mm.
So of course, in ExomTech, we are always your best AIoT partner. You know, as you can see, our tech line, your best AIoT partner. Very important also in our this AIoT mission. We provide some training, sharing. You know, so our tagline is we always innovate, we apply, and we share and we train. That is our tagline. And also one important thing is we sembang bukan sebarang sembang. What is that sembang when we do? You know,
We Sembang AIoT.
we sembang IoT, we sembang technology. So with that, we want to conclude our this sharing. Thank you very much for watching. You know, do SSL, subscribe, like, and share to all your friends who you think they are interested in this one. Thank you very much. See you again. Bye bye. A very nice weekend. Bye bye. See you.
Bye bye.